students, welcome back to our session. Today's session we are going to discuss trigonometric identity. Trigonometric identities and tables. Here we are going to see the learning sequence or introduction, trigonometric ratios, and their relationship. The next one, trigonometric identities. And the last one, trigonometric tables. And their use. So these are the learning sequence which we are going to discuss in this session. The first one, introduction. Trigonometry is a branch of mathematics that deals with the relationship between the sides and angles of a right angle and angles of a right triangle. Trigonometry is a branch of mathematics that deals with the relationship between the sides and angles of a right triangle. In the previous class, we have discussed about trigonometric ratios and trigonometric ratios of complementary angles. In this chapter, we shall study the basic trigonometric identities and use them in simplifying trigonometric expressions. We shall also learn how to use the trigonometric tables of a natural, sine, cosine and tangent. Before going to do this, so let us first know some basic concept that you have already studied in the previous class. The first concept, trigonometric ratios. And their relationships. There are 6 trigonometric ratios relating the 3 sides of a right triangle, like ABC is a right angle triangle. At B, the angle is a 90 degree. We used to call it as right angled at B. For the acute angles means A and C angles, it is going to be less than 90 degree. When it is less than 90 degree, we used to call it as acute angle. Now we have 6 trigonometric ratios. The first one, sine theta. Now I am going to consider theta is at C. Opposite to 90 degree, we used to call it as hypotenuse side. And opposite to theta, we used to call it as opposite side. Or even you can say it as perpendicular side. Now the leftover, the base, we used to call it as base. Even you can say it is adjacent side also. Okay, now let me see one by one. Sine theta is equal to perpendicular divided by hypotenuse side. or you can say it as opposite side divided by hypotenuse side. So perpendicular side is AB and hypotenuse side is AC. The second one, cos theta, or even you can say it as cosine of angle. Cos theta is equal to base divided by hypotenuse side, or you can say it as adjacent divided by hypotenuse side, is equal to BC divided by AC. The third one, tan theta is equal to perpendicular by base, or even you can write it as opposite divided by adjacent side. So it is nothing but AB divided by BC. The fourth one, cosecant theta. Cosecant theta is equal to inverse of sine theta. We used to call it as cosecant theta. Sine theta we have perpendicular divided by hypotenuse side, but here we need to take hypotenuse divided by perpendicular. Or we can write it as or hypotenuse divided by opposite side is equal to AC divided by AB. The fifth one, secant theta is equal to reciprocal of cos theta. So inverse of cos theta is equal to hypotenuse side divided by base, or hypotenuse side divided by adjacent side, is equal to AC divided by BC. Now the sixth one, cot theta. Cot theta is equal to inverse of tan, base divided by perpendicular, or we can write it as adjacent divided by hypotenuse side, is equal to BC divided by AB. Now just I want to explain the reciprocals. Reciprocal. Okay, now cosecant theta is equal to 1 by sine theta we have. So sine theta is equal to 1 by cosecant theta also we can write. Secant theta is equal to 1 by cos theta. Cos theta is equal to 1 divided by secant theta. Next, the reciprocal of the third one, cot theta is equal to 1 by tan. Tan theta is equal to 1 by cot. So this is the 6 ratios of the reciprocal. So this we used to call it as reciprocal relationship. From the reciprocal relationship, even we can find that when you shift this division to the opposite side, it will be multiplication. So cosecant theta into sine theta is equal to 1. When you shift this cos division to the opposite side, secant theta into cos theta is equal to 1. When you shift this tan to the opposite side, tan theta into cot theta is equal to 1. So this is formula where we found in the reciprocal relationship. Now we'll move to the quotient relationship. Quotient relationship. So the quotient relationship, we have only two formulas. One is tan theta. Tan theta is equal to sine theta divided by cos theta. The second one, cot theta is equal to inverse of tan. It is nothing but cos theta divided by sine theta. The next one, trigonometrical identities. So far we have discussed that we are the trigonometric ratios. Now let us study the basic trigonometric identities. An identity is an equation which is true for all the values of the variables involved in it. Thus, a trigonometric identity is an equation involving trigonometric ratios of angles and is true for all the values of angles. The basic trigonometric identities. Basic trigonometric identities. The first one, sine square theta plus cos square theta is equal to 1. The second one, secant square theta minus tan square theta is equal to 1. And the third one, cosecant square theta minus cot square theta is equal to 1. Now even you can express the above identities as, let it be here, sine square theta is equal to, when you shift this plus cos square theta to the opposite side, it will be 1 minus cos square theta. Cos square theta is equal to 1. When you shift this plus sine square to the opposite side, it will be minus sine square theta. Now from this identities, I am going to express secant square theta is equal to 1 plus tan square theta. Secant square theta, I am taking this tan square to the opposite side, so it will become plus, and this plus here it will become minus. So minus 1, secant square theta minus 1 is equal to tan square theta. Similarly, cosecant square theta is equal to 1 plus cot square theta. Cosecant square theta minus 1 is equal to cot square theta. To remember, sine theta whole square, we can write it as sine square theta cos theta whole square is equal to cos square theta. Okay, next I am going to teach you the trigonometric ratios of complementary angles. Trigonometric ratios of complementary angles. For an acute angle A, so here A it is going to be acute angle, so it will be less than 90 degree. A is acute angle. Now the first one, sine 90 minus A is equal to cos A. The second one, tan 90 minus A is equal to cot A. Third one, secant 90 minus A is equal to cosecant A. Similarly, now the fourth one, cos 90 minus A is equal to, here sine 90 minus A is cos. Cos 90 minus A value is sine A. Similarly, we are going to write for cot 90 minus A is equal to tan A. Sixth one, cosecant 90 minus A is equal to secant A. So this identities you have to remember.